This video is about getting information from drawn functions. A drawn function will have an x and a y-axis and will have some curve on it. It could be linear, it could be a function that looks like that, or it could be a quadratic, looks like this red one here. And you'll be asked things like, for example, where does it cut the x-axis, where does it cut the y-axis, what's its minimum point? You might be asked, where does it cross over with another function? So let's have a look at some examples and see if we can make sense out of this topic. Right, here's a function. It's a quadratic function. It's so it's going to be of the form x squared. In this case, we're given the function. It's 3 plus 2x minus x squared. The fact that it's minus x squared means it's n-shaped. If it was x squared by itself, positive x squared, it would be u-shaped. And we're told it's within the domain of minus 2 to 4. And as you can see, we're drawing it from minus 2 to 4. Okay, so use the graph. So you're just looking at the picture. You're not using the function. Use the picture to find the roots of the equation f of x equals 0. So what I do in this case, I see where does this function cross the x-axis? Where does f of x equal 0? And it's equal to 0 at x is equal to minus 1 and x is equal to 3. Next is what are the values of x for which f of x is equal to 3? So where is my function equal to 3? Well, it's equal to 3 at this point and this point. One nice way to do it is when I see f of x is equal to 3, I can do this. That's my f of x line is equal to 3. And where does it cross the curve? Well, it crosses the curve here and here. So this happens at x is equal to 0. That's where one thing happens. That's where it's equal to 3. And it's also equal to 3 at x is equal to 2. So the solution to this is when x is equal to 0 and x equals 2. Okay, next, what is the value of f 2.5? You notice this is a different structure to this type of question here. So f 2.5, I go along to what is my 2, and that's my input. So I go along to 2.5, and I go up and I see that f 2.5 is about 1.6, 1.7 maybe, about there. So that's equal to 1.6, 1.7. And because you're just using a picture, you are just working out your best guess. If you want to work out precisely what f 2.5 is, you put it into this equation here, and you work out exactly what it is. But we don't have to do that. We're just looking at the picture. So f 2.5 is equal to 1.8. Yeah. Okay, now part 4 is the maximum value of f of x. Well, I can see that's up to here. The maximum value is equal to 4. Okay, so I'll put that in a moment. The coordinates of the maximum point of f of x. Well, the maximum value is 4, but the coordinates is 1, 4. Okay, the range of values of x for which f of x is increasing. Well, the function is increasing from here, and the x value for that is minus 2. So it's increasing all the way along here, right up to the maximum value it's increasing. Then it's decreasing. So the range of values of x for which the f of x is increasing is minus 2 up to 1. So minus 2 to 1. So the range of values of x for which f of x is increasing will range from minus 2. X is going to be greater than minus 2 and less than 1. So there we are. The range of values of x for which f of x is positive. So where is this function positive? Well, it's positive above the x-axis and it's negative below the x-axis. So the range of values are going to be from minus 1 to 3. And the last part of this question is, what is the equation of the axis of symmetry of the curve? Well, the axis of symmetry goes through the maximum or the minimum point. So this green line is the axis of symmetry. If I was to rotate this function around this line, you'd get exactly the same thing. It's a symmetrical line. It's the axis of symmetry. So what is the number of this line? Well, this point here was 1. Right here is 1. X is equal to 1 here. So you're going to find everywhere along this line, the value is going to be 1 comma something. 1, 0, 1, 1, 1, 2, 1, 3, 1, 4, 1, minus 1. So this line is called x equals 1. Right, let's have a look at another example. Now this question, it doesn't draw the graph for you. It's asking you to draw your own graph. It says, draw the graph of the function f of x is equal to this in the domain of that, and use your graph to find these. So we're going to draw the graph first. So let's do that. Why don't you do a little table like this? You know, this table here, you have your x input, then you've got the 2x squared minus x minus 3, and you have your output here, y. Do that table. Press pause in this video and you do the table, and I'll do it as well, and then you can check your answers. It's a good idea. And it's going to go from minus 2, minus 1, 0, 1, 2, 3. Okay, so press pause and have a go at that, and I'll see you in a moment. right? You should compare your table against my table, make sure you've got the right results, and then you plot out your curve. Try to make your curve as nice as possible. Make sure you don't do things like this, you know, have it angular. That would be incorrect. You must try to make it one smooth, nice long curve. And if your points are incorrect, you know, you can fix them afterwards, but make sure it's going to be nice and smooth. Okay, it's the first thing. Okay, so minus 2, 7. Let's have a look at that. That's the first point. So minus 2, and we're going to go up to 7, and there it is indeed. Minus 1, 0. So that's one of our roots, or where across the x-axis, minus 1, 0. The other point where across the x-axis looks like about 1.5, and so on. 0, minus 3. So where it cuts the y-axis is 0. X is equal to 0, minus 3. So there we are. It looks like the curve goes slightly below that. You see there's 0, minus 3, but the curve goes slightly below that. Let's answer the questions. The values for x for which f of x is equal to 0. So we know that f of x, the function, is equal to 0 when x is equal to minus 1 and x is equal to 1.5. Okay, so there's the answer to that. X equals minus 1, x equals 1.5. The values for x for which f of x is equal to 6. So where is this function equal to 6? So it's equal to 6 along, here's my output. F of x is equal to 6. I can draw a line across here. Okay, you'll have a straight line with a ruler all the way across. I don't have the luxury of that. But I can see that when f of x is equal to 6, that means it looks like that x is equal to about 2.3 maybe. And here when x is equal to 6, I'm going to drop a line down here. It's really shockingly bad this thing is here. But minus 1 point. Maybe 1.8, I'm looking here. What do you think? About minus 1.8, okay? So you're going to have your two values when x is equal to 6. Draw a line across the 6 line and then draw the lines down from where they intersect. And you're going to get maybe minus 1.8 and 2.3. I changed my mind when I looked at this. I think it looks closer to 2.4 than 2.3 because this line right here is in the middle. That's 2.5. So say 2.4. But anyway, there will be a bit of leeway when you make that estimate in your exam. It won't be there's definitely leeway in it. So the coordinates of the minimum point of the curve. So well, the coordinates of the minimum point look like it's, I'd say, about around there somewhere. Okay. And I can't be precise with my pen, but I'm looking at it and it looks like to me it's maybe a quarter, maybe about a quarter, and then minus 3.1, something like that. A quarter minus 3.1, comma minus 3.1. Okay. Okay, so there's my coordinates, I think, and a quarter minus 3.1. And finally, which values for x are when the values for x for which f of x is less than 0. So where is this function less than 0? Well, it's less than 0 down here. Okay, so this part of the curve is less than 0. So the values for x for which is less than 0 are x equals between minus 1 and 1.5. So the way you write that is, I'll do it up here. So the function is less than 0. It's negative between minus 1 and 1.5. So x is greater than minus 1 and x is less than 1.5. Okay. Okay, here's another type of question you can be asked. They will show two functions on the same graph. A quadratic, which is f of x is equal to x squared, and a linear one, which is g of x is equal to 2x plus 3. But again, you're looking at a graph, you can just use the picture. So write down the coordinates of the point where the curve and the line meet. This coordinate here looks to me like minus 1 plus 1. And the other place where they meet is maybe 3, 9. The next question reads part 2. Solve the equation x squared is equal to 2x plus 3. Well, x squared is our curve and 2x plus 3 is our line. So solve the means when do they cross over at each other. And in this case, what values for x make this true? Which values for x make x squared equal to 2x plus 3? Well, we've just identified them, minus 1 and 3. If I put minus 1 in here, I'm going to get, no, I just have to look at the picture to do it, but if I do put minus 1 into this equation, I get minus 1 to be squared is plus 1, and I get minus 1 multiplied by 2, that's minus 2 plus 3, that's equal to plus 1 as well. Equally, if I put 3 in here, I'm going to get 3 squared, that's equal to 9, and that's equal to 2 3s, 2 times 3 is 6, plus 3 is equal to 9. So that's the same. So your answer to this question is x equals minus 1 and x equals 3. What is the connection between the answers in 1 and 2 above? Well, the answer to this would be that the connection is that they have the same x values. We have a -1 and a -1 and a 3 and a 3. So the same x values. Explain the meaning of the equation f of x is equal to g of x. So when is f of x equal to g of x? Well, what this question means is when are the outputs of the functions the same? So when we put a -1 into the quadratic, we get 1. When we put a -1 into the linear function, we get a 1 as well. When we put a 3 into the quadratic, we get 9. When we put a 3 into the linear function, we get a 9. So that's what it means. You're finding out when are the outputs of the functions the same. Okay, and the last section we will have a look at. Now, the first part of this you've seen before, use the graphs to solve these equations, 3x minus x squared. This, and in the question, it does say y is equal to 3x minus x squared. That's what this function is. And we're trying to work out where is it equal to 0. Well, it's equal to 0 at x equals 0 and x equals 3. The other part which you haven't seen yet, well, you have, but in different ways, is what solve the equation 3x minus x squared is equal to -3. You'll notice it's the same function as 3x minus x squared here. It's the same function, but it's just equal to -3. So all we do is we just draw a line through -3 and work out where is that true. Where is that function equal to -3? So what you do is you'll get a ruler. I can't use one here, but I draw a line straight from here up to here, and I see it's 3.246, maybe 8. 3.8, that's x equals 3.8. That's when it's equal to -3. And where's the other point where it's equal to? Maybe here as well. And it's minus 0.8. X equals minus 0.8. Again, use a ruler. In your case, I can't use a ruler on this application. So that's when it's equal to -3. And let's have a look at the other one now. Okay. So we're now looking at the function x squared minus 3x minus 4. Here it is here. X squared minus 3x minus 4. And we're saying use your graph to solve these equations. When is this equal to 0? So x equals to -1 and x equals 4. That's when they're equal to 0. Where is it equal to -2? Okay, well, you can draw a line at x equals -2 here, all the way across. Use your ruler. And I can see it looks at about this point here and this point. If I drop a line up to the graph, it'll be maybe, looks like about 3.5, 3.6, sorry, 3.5 maybe, and over here it's going to be minus 0.5. So I think they'd be my guesses, but you'll be doing it more accurately than me. So this function is equal to -2 at x equals minus 0.5 and x equals 3.5. Okay.